Our solar system, as vast and familiar as it seems, may be hiding a secret that could rewrite our understanding of planetary formation and the very architecture of our cosmic neighborhood. That secret is a massive, unseen world lurking far beyond Neptune, a hypothetical giant shrouded in mystery and darkness that scientists have dubbed Planet 9. Its existence, while not yet confirmed, is supported by compelling evidence that has captivated the astronomical community. The story begins in the Kuiper Belt, a region beyond Neptune populated by icy bodies and remnants from the solar system's formation. Astronomers noticed that several Kuiper Belt objects, or KBOs, have clustered, tilted orbits, an unusual alignment that defies conventional models of the outer solar system. This peculiar clustering hinted at a hidden gravitational force, a subtle but persistent influence shaping the orbits of these distant objects. Something massive, yet unseen, was seemingly orchestrating their movements. This anomaly led to the Planet 9 hypothesis, a bold proposition suggesting the existence of a large undiscovered planet lurking in the far reaches of our solar system. This wouldn't be just any planet. Planet 9 is theorized to be a giant planet, 5 to 10 times Earth's mass, making it significantly larger than our own world. And not only is it massive, but it's also believed to be on a vast elliptical orbit, taking it incredibly far from the Sun at its farthest point. This elongated path would explain its faintness and why it has remained hidden for so long. Calculations by astronomers like Mike Brown and Konstantin Batygin, using sophisticated computer models and observational data, pointed to this planet as the only plausible explanation for the KBO's strange alignment. The math simply didn't add up without the gravitational influence of a massive distant object. Imagine small boats all leaning the same way on a calm lake, an unnatural alignment that begs for an explanation. You'd immediately suspect a large, unseen ship had passed by, creating a wake that influenced the smaller vessels. The KBOs are those boats. Planet 9 is the ship, its immense gravity subtly guiding their orbital paths. And so, the search began for a faint, slow-moving point of light, a needle in a cosmic haystack. This elusive object is estimated to be hundreds of times farther from the Sun than Earth, placing it in the frigid, dark depths of the outer solar system. Its immense distance makes it almost impossible to spot with regular telescopes, requiring specialized instruments and techniques. Finding it is like searching for a dark bowling ball in an unlit field the size of a continent, a daunting task that demands ingenuity and perseverance. The hunt required new strategies, patience, and creative use of decades-old data, sifting through vast archives of astronomical observations for any hint of Planet 9's presence. Undeterred by the challenges, astronomers set out to find our solar system's missing member, driven by the thrill of discovery and the potential to revolutionize our understanding of the cosmos. They are using every tool at their disposal, from powerful ground-based telescopes to sophisticated space-based observatories, all focused on unraveling this cosmic mystery. The stage was set for one of the greatest astronomical searches of our time, a quest to find a hidden world and redefine our place in the universe. How do you find a planet that's nearly invisible? By searching for its heat, not its light. Even a frigid world like Planet 9 would glow faintly in infrared, thanks to leftover heat from its formation. Astronomers turned to old infrared surveys, IRAS, 1983, and Akari, 2006, which mapped the sky decades apart. If Planet 9 existed, it might appear as a faint, moving dot in both datasets. The challenge filter millions of infrared sources, removing stars, galaxies, and dust, to find a single object that moved just the right amount over 23 years. This was a high-tech search for a cosmic needle in a haystack. By comparing these archives, astronomers hoped to spot the subtle motion of a distant world. The search for Planet 9 was an exhaustive endeavor, a cosmic treasure hunt spanning years and requiring the analysis of vast amounts of astronomical data. After sifting through millions of sources from archived telescope observations to cutting-edge surveys, the team found 13 promising pairs of infrared signals. These signals stood out from the background noise, hinting at the possibility of a distant, undiscovered object lurking in the outer reaches of our solar system. Each was checked by hand, a meticulous process requiring careful scrutiny and expert judgment. Cross-referenced with catalogs, both modern and historical, to eliminate known objects and artifacts. The team compared the signals against a comprehensive database of celestial bodies, and most were ruled out as galaxies or dust clouds. These distant objects, while fascinating in their own right, were not the elusive planet the team was searching for. One candidate remained: a single point of light that defied easy explanation. A faint source in both the 1983 and 2006 data, spanning over 2 decades of astronomical observations. This temporal consistency was a crucial clue, suggesting that the object was not a transient phenomenon, but a stable, long-term resident of our solar system. Moving just as a distant planet should, its slow, deliberate motion across the sky was a telltale sign of its great distance and orbital path. Its position suggested it was 500–700 times farther from the Sun than Earth, placing it far beyond the orbit of Neptune in the frigid depths of the outer solar system. And its infrared brightness matched predictions for Planet 9. The object emitted a faint but detectable amount of infrared radiation, consistent with the expected temperature and size of a planet at such a vast distance. For a moment it seemed the ghost had been found. The elusive Planet 9, a hypothetical world that had captivated astronomers for years, might finally be within reach. The astronomical community buzzed with excitement. A wave of anticipation rippled through observatories and research institutions around the world. Had we finally discovered our solar system's 9th planet? The prospect of adding a new member to our planetary family was a thrilling possibility. The discovery showcased the power of archival astronomy, demonstrating the value of preserving and reanalyzing old data with new techniques. New worlds could be hiding in old data. The universe is full of surprises, and sometimes the most groundbreaking discoveries are waiting to be unearthed in the archives. The next step was crucial: to confirm the object's existence and determine its true nature. Analyze the object's orbit to see if it matched Planet 9's predicted path. This involved complex calculations and simulations, taking into account the gravitational influence of the Sun and other planets. This would be the ultimate test, a make-or-break moment for the Planet 9 hypothesis, confirmation or disappointment. The fate of Planet 9 hung in the balance. The world watched as astronomers prepared for the moment of truth. Telescopes around the globe were trained on the faint object, ready to gather the data that would either confirm or refute its planetary status. The excitement quickly faded as astronomers calculated the candidate's orbit. Planet 9's theory requires a planet in the same general plane as the other planets, on a long, stretched-out path. But this object's orbit was wildly tilted, almost perpendicular to the solar system's plane. Instead of following the grooves of the solar system's disk, it cut across at a steep angle. Its inclination was about 120 degrees, meaning it moved in the opposite direction to the other planets. This was a major red flag. Its gravity would pull in the wrong direction to explain the KBO's clustering. The mismatch was fundamental, not minor. The candidate's orbit simply didn't fit the theory. The search for Planet 9 was back to square one. Planet 9 was proposed to explain the strange, clustered orbits of distant trans-Neptunian objects. For this to work, the planet must be in the right place on the right path to shepherd these icy bodies. The 2025 candidate's bizarre, highly inclined orbit fails this test. Its gravity would pull objects up or down, not into the neat cluster we observe. It's like trying to herd sheep from a helicopter. You can't guide them into a pen. The candidate's existence doesn't solve the original puzzle. It only deepens the mystery. If real, it's a new object, but not the one we're looking for. The search for the true Planet 9 must continue. The announcement of a potential Planet 9 candidate in 2025 sent ripples of excitement through the astronomical community. However, the scientific process demands rigorous scrutiny, and the response was swift. After careful examination and analysis of the object's characteristics and orbital parameters, the verdict came in. The 2025 candidate is 100% not Planet 9. Mike Brown, the Caltech astronomer and co-creator of the Planet 9 hypothesis, known for his role in the demotion of Pluto and his subsequent search for a true 9th planet, was unequivocal. The orbit of this particular object is so fundamentally incompatible with the predicted characteristics of Planet 9 that it can be ruled out with absolute certainty. The orbital path simply doesn't align with the theoretical models. Planet 9 isn't just any distant object lurking in the outer reaches of our solar system. It's a very specific prediction, a hypothetical planet possessing a certain mass range, residing on a very specific and highly eccentric orbit, and crucially causing a specific and observable gravitational effect on other objects in the Kuiper belt. Therefore, if a candidate object's characteristics don't align with these very specific parameters, it simply isn't Planet 9. No matter how large, how distant, or how intriguing it might otherwise be. This episode perfectly illustrates science in action, the core principles of hypothesis formulation, prediction generation, rigorous testing, and ultimately, the crucial step of rejection when the accumulating evidence simply doesn't match the initial hypothesis. While the initial headlines may have sparked a surge of hope and anticipation among space enthusiasts, the underlying reality, as always in science, was far more nuanced and complex, demanding careful interpretation of the data. And so, the narrative quickly shifted and the story became, a new strange object has been found in the outer solar system, an object that, while interesting in its own right, ultimately complicates rather than confirms the ongoing search for the elusive Planet 9. This seemingly subtle distinction truly matters because it underscores the inherent rigor and self-correcting nature of the scientific process itself. Rejecting the 2025 candidate wasn't a setback or a failure of the hypothesis, but rather a successful and vital test of the Planet 9 theory, refining our understanding and narrowing the search parameters. It definitively clarified what Planet 9 is not, eliminating one possibility from the vast cosmic haystack, thereby sharpening the focus and direction of the ongoing search for the real Planet 9. The 2025 candidate's discovery did more than miss the mark. It threatened the entire Planet 9 hypothesis. If both this object and Planet 9 existed, their combined gravity would destabilize the outer solar system. Two massive planets couldn't coexist out there, their orbits would eventually eject one. The delicate alignment of the Kuiper Belt objects would be impossible with both present. Ironically, finding this candidate could mean Planet 9 doesn't exist at all. If the candidate is real, astronomers may need to rethink the original evidence. Maybe the clustering is a fluke or caused by something else. If it's a data artifact, the search continues as before. The hunt for one ghost may have revealed another, forcing us to question the original theory. Even though the 2025 candidate wasn't Planet 9, the search was far from wasted. The process pushed the limits of archival data analysis and proved that comparing decades-old infrared surveys can reveal new objects. It stress-tested the Planet 9 hypothesis, showing scientists could decisively rule out mismatched candidates. The episode sharpened the focus of future searches. We're not just looking for any planet, but one with very specific traits. It also highlighted the importance of clear scientific communication and the self-correcting nature of science. Whether the candidate is real or not, the search has enriched our understanding of the outer solar system. Every search, even a false positive, brings us closer to the truth. The dismissal of the 2025 candidate isn't the end for Planet 9, it's just another chapter. The original gravitational puzzle remains unsolved, and the search continues with new tools and sharper focus. The Vera C. Rubin Observatory, soon to open in Chile, will survey the southern sky with unprecedented depth and speed. Its massive digital camera will track faint, slow-moving objects perfect for hunting Planet 9. If Planet 9 is out there, the Rubin Observatory is expected to find it, or rule it out, within a few years. The story of the 2025 candidate was a dress rehearsal. Now, the main event begins. With new technology, we may soon learn if a hidden giant shapes our solar system or if the ghost in the machine was just a phantom all along. The universe is about to reveal its secrets, and all we have to do is watch.